says both 4 and the rod. No, it's only the 4 that can absorb the positively charged, not the rod. If I want the rod to absorb negatively charged, positive charge, I have to rub the glass rod with silk. Not ebonite rod this time, a glass rod. Rub it with silk. You have charged that body positively. But if I have an ebonite rod and rub it with, charge that body negatively. So the answer to this question is option A. So when I bring an ebonite rod, rub it with 4, the 4 will acquire positively charged, leaving the rod negatively charged. So I have charged that rod negatively. So that is the answer to this option. Of this question, option A is the correct answer to this question. Okay? Remember, a charged body has both electrons and neutrons embedded in them. Okay? Let's go over to question number 3 for today. Question 3 is from 2021. 2021, 24. A converging lens has a focal length of 20 centimeters. The lens forms a real inverted image of the same side. As the object. When the object distance is, option A, we have 40 centimeter. Option B, we have 30 centimeter. Option C, 20 centimeter. And option D, we have 10 centimeter. Okay? Now, I read the question again. Question number 24 in the year 2021. A converging lens has a focal length of 20 centimeters. The lens forms a real inverted image of the same size as the object when the object distance from the lens is, option A, 40 centimeters, option B, 30 centimeters, option C, 20 centimeters, and option D. First and foremost, you have to, in as much as you have just 1 minute to answer this particular question, you write out your parameters. What am I giving? What am I looking for? Which formula do I use to solve? So F, solution. F, which is the focal length, is giving us what? 20 centimeters. 20 centimeters. Now, the lens form a real inverted image is of the same size as the object. It means that object is magnified. Is magnification. It means the object is what? Magnified. It's magnification. So M is equals to V all over U. And this is the formula for magnification of length. M is equals to V all over U. Where your U is equals to V. Where your V is equals to U. Now, having known that, using the lens formula, I have 1 over F is equals to 1 over V plus 1 over U. 1 over F is equals to 1 over V plus 1 over U. This is the lens formula. And I'm giving what? The focal length as 20 centimeters. I said when the lens form a real inverted image of the same size is what? Magnification. That is magnification. So M is equals to V all over U. M is equals to V all over U. And your V is equals to U. Your V is equals to U. Now, using the lens formula, we have 1 over F is equals to 1 over V plus 1 over U. In that case, okay, let's continue. 1 over F is equals to 1 over V. Remember I said V is equals to U. So I'm changing my V towards to U. 1 over U plus 1 over U. Now, 1 over F is equals to, I find the LCM of U and U is U. The LCM of U and U is U. So U into U, 1 times 1, 1, plus U into U is U, 1 times 1 is 1. So I have 1 over F is equals to 2 all over U. Is equals to 2 all over U. What do? I cross multiply. I have 2F is equals to U. U times 1, U. 2 times F is 2F. Now, 2F. Remember, U becomes 2F. I'm asked to find the object distance, which is U. Your U represents the object distance, is unknown. Now, U is equals to 2F, and F is 20 from our question. The focal length is giving us what? 20. So U becomes 2 times 20, which is equals to what? 40 centimeters. So the answer to this question is answer number option A, 40 centimeters. I go through it again. Now, a converging lens has a focal length of 20 centimeters. The lens forms a real inverted image of the same size. Once the lens forms a real image, inverted image of the same size is magnification. Okay, so okay, as the object, when the object distance from the lens is, I'm also find the object distance, which is what? U. Now, F is giving us 20 centimeters. And then M is equals to V all over. From the formula for magnification, M is equals to V all over U. And I said V is equals to U. V is equals to U. Now, using the lens formula, I have 1 over F is equals to 1 over V plus 1 over U. Remember I said our V is equals to U. So I change my V to U. So it becomes 1 over U plus 1 over U. So I look for the LCM of U and U is U. U into U is 1. 1 times 1 is 1. Plus U into U, 1. 1 times 1 is 1. 1 plus 1 is 2 all over U. So 1 over F is equals to 2 over U. So what do? Cross multiply. I have U times 1, U. 2 times F is 2F. And U is equals to 2F, where F is the focal length giving us what? 20. So 2 times 20, I have 40 centimeters. So I have, so the 40 centimeters. If the focal length is 20 centimeters, the object distance is 40 centimeters, which is also that the image distance is also 40 centimeters because U and V is the same. Object distance and image distance is the same in this question, which is 40 centimeters. But the focal length is given to us as 20 centimeters. If you have any, do it together. Okay, for those of us who is coming in for the very first time, we are going live, teaching you on what you are expected to see during your forthcoming JAMB examination. And so, wherever you are watching from, you have any questions, just drop it, I will give you an answer. Okay, let's go to question for today. Remember, again, you have just 1 minute to a question. 1 minute to a question. You have to be very fast as possible. Once your time elapses, your system will shut down. So do yourself a favor, as many formulas as possible, know them. And then be very fast in your speed, in your calculation. That's what counts. When it comes to physics, mathematics, chemistry, your speed has to be in place. You must be very fast in calculation. And your formulas should be up there. Okay, now question number 20. Okay, the year 2022. Question number 10. An object is projected at 30 degrees centigrade of the horizontal with a velocity of seconds. What is the maximum height attained G is equals to 10 meters per second square? Okay, I repeat the question again. An object, this one is from 20 at 30 degrees Celsius of a 30 degrees of the horizontal with a velocity of 20 meters per second. What is the maximum height? What is the maximum from projectile? From projectile. So at this stage in projectile, you should know the formulas for calculating the maximum height, formula for calculating range, calculating time of flight. These formulas should be embedded in you. But in this case, we are asked to find the maximum height. The maximum height. So what and what is given? First of all, I am given theta as 30 degrees. I'm given u, which is velocity, as 20 meters per second. I'm equally given h is unknown. Although g is given as 10 meters per second square, h is unknown. Maximum height. The maximum height. Now, I said first thing you do is to write out your parameters. What am I giving? What am I looking for? What formula will I now apply? Now, it's from projectile. The theta to the projectile angle is 30 degrees with a velocity of 20 meters per second. I'm giving g as 10 meters per second square. Now, but the h, I'm asked to calculate what is the maximum height? What is the maximum height attained? Which is what? H is unknown. So, having known that, to get height of a projectile, you're having u squared sine square theta all over 2g. U squared sine square theta all over 2g. Please, there's a difference between sine square theta and sine 2 theta mathematically. Sine 2 theta and sine square theta is two different things. So we should be conversant with our calculation. Okay? Now, having known that, to get the maximum height, h is equal to u squared sine square theta all over 2g. So, our u is, what about u? 20. H is equal to 20 square sine square 30 all over 2 times 10, because I'm giving g as 10. I'm giving g as 10. Okay? H is equals to 20 square is 400 times sine 30 is 0.5. 0.5 square all over 20. I have 2 times 10 is 20. 20 squared is 400. Then sine 30 is 0.5. Remember, it's sine square theta, not sine 2 theta. Sine 2 theta means 2 times the sine of 30 degrees. Sine square theta means the square of sine 30. So there are two different things. So we should be conversant with our formulas for range, for time of flight, and for maximum height when it comes to projectile. It's okay. We have H is equals to 400 is equals to 100 all over 20. If I multiply 400 times 0.5 square, I'm having 100. Divide by 20, I have H is equals to 5 meters, which is option number, I didn't give you options. So sorry. The question says again, an object is projected at 30 degrees of the horizontal with a velocity of 20 meters per second. What is the maximum height attained, given that G is 10 meters per second square? And option A is 10 meters, option B is 20 meters, option C is 5 meters, and option D is 2 meters. So the answer to this question is option C, which is 5 meters, which is 5 meters. I said again, I said the first thing you do is write out your parameters. What am I looking for? What am I given? I'm given the angle as 30 degrees. I'm given velocity as 20 meters per second. I'm also giving G, which is what? Acceleration due to gravity, as 10 meters per second square. And I'm asked to find the maximum height, H. And I said, this question is coming up from projectile. And I said in projectile, you have to know the time of flight, the maximum height. And now for maximum height, the formula is U squared sine squared theta all over 2G. U squared sine squared theta all over 2G. So I have to fix all these things into the formula. Remember, there's a difference between sine squared theta and sine 2 theta. So when you're calculating, don't go and multiply sine by 2. Sine 2 theta means 2 times the sine of theta. Sine squared theta means the sine of theta times, that is, multiply it twice. That's assuming that we have sine 30, the angle here is 30 degrees, let's say 0.5. 0.5 times 0.5, that is square theta. But sine 2 theta means 0.5 times 2 is 2 different things. So the formulas may be confusing, but just try and know them and understand them. So, okay, let's continue. U squared sine squared theta all over 2G is the formula to calculate the maximum height. H is equals to U is given as 20. Sine 30 is square all over 2 over 10. The square of 20 is 400. Sine 30 is 0.5 square. That is where the sine squared comes in. So all over 20. 400 times 0.5 square, you're having 100. Divide by 20, I have 5. So the maximum height to be attained is 5 meters. It's 5 meters. I believe we are doing justice to these questions, and we are gaining something. To my viewers, to my students, I hope this is very clear. Hope you are gaining something. If you have a question, feel free to ask a question from any area. We're ready to do justice to it. Okay. Next question for today. Okay. Question 6 for today is from 2023. The year 2023. Question number 5. A uniform meter rule AB balances on a knife edge. $60 centimeters from the end B when load of 22 gram is kept 10 cm away from the end A. Now, what is the weight of the meter rule? Option A, 40 grams. B, 55 gram. Option C, 66 gram. Option D, 37 gram. Okay. Now the question for this, for today, for this year 2023, question 5. A uniform meter rule AB balanced on a knife edge 60 centimeter from end B, when load of 22 grams is kept 10 cm away from the end A, what is the weight of the meter rule? What is the weight of the meter rule? The first thing you do is you picture the diagram, how it's going to look like. Now, you know what a knife edge is. I'm talking to my physics student, I know you know what knife edge is. And then you know a meter rule. Want to use in the lab is always 100 centimeter long, 100 centimeter long, and it's placed on the knife edge. So first thing we do, we just draw the meter rule on a knife balances at what? 60 centimeter. Now this is a knife edge on a meter rule, and it says, okay, when the load of 22 gram, when the load of 22 gram is kept 10 cm away from A. First of all, this is A and this is B. Now, 10 cm, which means from here to here is 10 cm. If from here to here is 10, and from here to here is 60, and the length of the ruler is 100, what do you think from here to here would be? 40 centimeters. Okay, now let's continue. Now, from here to here to the ending is 60 centimeter. In other words, so from here, I'm asked to find the weight, W, of the meter rule. The weight of the meter rule. Now, the weight of the meter rule from here to where the weight will be is 10 cm. 10 cm apart. Now, if here to here is 10 cm, and from here to here is 60, what do you think from here to here will be? 50. So here to here will be 50 centimeters. And I'm asked to calculate what? I'm asked to calculate what? W. Okay, no, this is 30. Yeah, thank you. I can hear that. If the meter rule length is 100 cm, which is always the same in the lab, is 100 cm, and is 60 meters from B, and 10 cm from A. If from here to here, from where the knife edge is to B is 60 centimeters, which means from here to here is 40. So if here to here is 10 from our question, the balance from here to where the knife edge is 30 centimeters. 30 centimeters. 30 centimeters. And then if from here to here is 10, which means from here to the ending is also 50 centimeters. If I add all together, we must get 100 centimeter length of the meter rule. But I'm asked to calculate the weight. The weight on the meter rule. The weight on the meter rule. Now, this question is going out from the moment of force. Moment of force. And now, what is the rule that governs the principle of moment? One of the rules says the clockwise moment must be equal to the anti-clockwise moment. What I'm doing to A, I should also do it to B. The clockwise moment must be equal to the anti-clockwise moment. The downward force must equate to the inward force, the upward force. So the upward force and the downward force should be the same, using the principle of moment. Then the clockwise moment must be equal to the anti-clockwise moment. Now, I'm asked to find the weight on the meter rule. So, clockwise moment is equal to anti-clockwise moment. So I have 22 times 20 this way. 22 times 30 is equals to W times 10. The clockwise moment must be equal to anti-clockwise moment. So 22 times 30 is equals to W times 10. I am asked to look for W. Now, having known that, so 22 times 30 is equals to W times 10. So 22 times 30, you are having 660 is equals to W10. Then W is equals to 660 all over 10. And W is equals to 66. I have 66 grams, which is option number C. So 66 grams, we're able to balance the gram on the other side. Remember, it is not, the knife edge is not exactly at 50 centimeter point. It's at 60. It's at 60. It's balancing at 60. But if I have a 100 meter rule, then the length, if the length is 100, the balance point should be at 50. But in this case, the balance point is at 60 centimeter. And so, and 10 cm from A. If here is 10 cm, which means from here to this place should be remaining 30. 30 plus 10 is 40. 40 plus 60 is what? 100 cm. Or if I say 30 plus 10 is 40. 40 plus 10 is 50. 50 plus 50 is 100 centimeter. So if you break it down that way, knowing that your W is equals, W times 10 is equals to 22 times principle of moment. And the inward force, downward force must equal to the upward force. The clockwise moment must be equal to the anti-clockwise moment. So we have CW, which is clockwise moment, must equal to the anti-clockwise moment, which is 22 times 20. Sorry, 22 times. So having known that 22 times 30, I'm having 660. W times 10, I have W10 or 10W, as the case may be. So W now becomes 660 all over 10. I'm having 66 grams. So the weight on the meter rule is 66 grams. That makes option number C very, very correct. I believe we are clear. And will answer you. Remember, every topic you've been taught has a formula and has an SI unit. Now, the SI unit for weight is also in gram. It's gram. So you should take note of that. Then, the formula, very, very important. Every topic being taught in physics has its own formula and has a principle to apply them. So as much as possible as you can, try to embed them, put them at the back of your mind, in front of your mind, as some students will say in front of their mind, or your memory. Let it be sharp to pick as many formulas as possible. Once you can pick one, applying them will not be a problem. And understand the question vividly so that you don't make mistake. Okay. All right, let's run through one more question for today. One more question for today. If you want, we are going around all areas. For today now, we went through projectile, we went through expansivity, we went through moments of force. And so we are picking questions from all areas in physics. Okay? Okay, let's do one more question for today. I think, okay, Okay, the last question for today is 2023, question 14. 2023, question number 14. Okay. Okay. In the given circuit, what is the ammeter capacitor, ammeter reading, given that the voltage across the capacitor and inductor are 300 volts each. Option A, I have 1.2 ampere. Option B, I have 2.2 ampere. Option C, I have 3.2 ampere. And option D, I have 0.2 ampere. Okay. Now, this question is from 2023, question number 14. Now, there's a diagram on the board showing the resistor, the indicator, inductor, and the capacitor. They are all connected in series to an ammeter. Now, in a given circuit, what is the ammeter reading? What is the ammeter reading? Given that the voltage across the capacitor and the inductor are 300 volts each. Now, this question is called from impedance. Impedance. Now, impedance is the opposition of affected by capacitor and inductor through the flow of an AC flowing through them. Now, having known that, it has a formula that says Z is equals to the square root of XL minus XC all squared plus R squared from impedance. And we said impedance is the opposition affected by inductor, capacitor, that is through the flow of an AC current flowing through them. Now, and Z is equal to the square root of XL, which is inductor, C is capacitor, and R is resistor. But in this case, we are asked to calculate we are given the voltage across the capacitor and inductor as 300 volts each. So what do I need to do? Now, calculating first of all the potential difference. So first of all, having known that the potential difference between each of them, we have V is equal to the square root of XL minus XC all squared plus R squared. And then we have V is equal to the square root of VL minus VC all squared plus VR squared. VL, which is inductor, VC, and the voltage across, the VL represents the voltage, the potential difference across the inductor, Then VC represent the voltage potential difference across the capacitor, and then VR represent the potential difference across the resistor. So you have resistor, you have inductor, and you have the capacitor. And then the flow of AC through them is what we call the impedance. So you have VL minus VC all squared plus VR squared. And I'm asked to find the ammeter reading. Find the ammeter reading. And I'm giving my V as 200. V is 200 from our question is equals to the square root of VR squared plus VL minus VC all squared. Now 200 is given to us from the question. The potential difference across each and every one of them is 200 volts. So we have 200 is equals to V square root of VR, which is the resistor, which is not given to us. The voltage or potential difference across the resistor is not given, but it's given in inductor, given in capacitor. So you have plus, you have 300 minus 300 all squared. Whether it's squared, as long as 300 minus 300 is 0. Squaring 0 is also 0. 200 is equal to the square root of VR squared. VR squared. Mathematically, this square can cancel this. So I have 200 is equals to VR. 200 is equals to VR. 200 is equals to VR. Remember, from R is equals to V all over R. V I is equals to V all over R. From your Ohm's law, I is equals to V over R. Even in impedance, I is equals to V all over R. So we have our V as 200 and our R as 100 from our diagram. So you have, if I divide this to A is equals to 2.2 ampere or 2.0 ampere. 2.20 ampere. So that is the answer to this question. Option number B becomes the answer to this particular question. I go over it again one more time. And this is the diagram given to us from the question. And we are also asked in the given circuit, what is the ammeter reading, given that the voltage across the capacitor and inductor are 300 volts each. And I said this question is coined out from impedance. And what is impedance? Is the opposition of affected resistor, inductor, capacitor flowing through an AC through them. Allowing the AC current to flow through them. That's an impedance. And the formula is given as V is equals to XL minus XC all squared plus R squared. But in this case, we are giving them in voltage. So I have V is equals to VL minus VC all squared plus VR squared, all in square roots. Now the VL is representing the potential difference across inductor. The VC is representing also potential difference across the capacitor, while VR is the potential difference across the resistor. Now, having known that the voltage across all is 220 volts, it's 200 volts from our question, sorry, 220, okay? 220 volts. Okay, let's go back again so that it becomes clearer now. 220 volts from our question, from a diagram, is 200. Now, VR, which is the potential difference across resistor, was not given to us. Plus, the potential difference across inductor is given as 300, and as capacitor is also 300. 300 minus 300 squared is 300, so it's gone. So 220 is equal to the square root of VR squared. So if mathematically I have squared here, and have a square root. If I cancel this from this, I'm having 220. 220 is equals to VR. 220 is equals to VR. From our Ohm's law, I is equals to V all over R, because I'm asked to calculate the ammeter reading, which is the current. Ammeter is an instrument to measure current. So ammeter, what is the ammeter reading from this circuit? So I is equals to V all over R, and I'm giving my V as 220, 220, and R is given as what? 100 ohms. 100 ohms. So if I divide 100 by 220, I'm having 2.20 ampere. So the answer to this question is answer option number B, 2.2 ampere. 2.2. So 2.2 ampere is the current reading at the ammeter, which is the instrument for measuring current in this circuit. I believe we have done enough for today. If you have any questions, feel free to ask us, and we're encouraging those of your friends who are still yet to join this academy should please join. We are doing everything we can to make sure you come out with flying colors at the end of your JAMB examination. Questions from all areas. We're going out questions from all areas from the past years. I think the last two classes we did from as far back as 1995, as far back as 2000. We're going through questions from all areas. And so do yourself a favor, encourage your friends to join you as we come live Thursday on physics. So stay blessed and see you next week.